All right, so what we're going to be doing today is practicing making a line for a scatter plot and writing an equation for that line. So what we've done so far has been a little bit easier equations, just saying, for example, height equals arm length or arm span. And there are definitely more difficult relationships between variables that we can graph. And so we're going to start with looking back at this peanut butter data, and there's a scatter plot here that relates the sodium content and the price. And so what I would first do is I would first think about our correlation. So just remember that just means the relationship between our variables. And it's possible for there to be no correlation. Otherwise, we have to decide if it's going to be a positive or a negative correlation. And so when I'm looking at sodium content and price, what I'm going to do is I'm going to look down here on the x-axis, and I'm going to look at it from left to right. And as it's increasing, I'm going to think about what the other variable is doing. So as I look at the lowest price that I have marked here, maybe between 5 and 10, I notice that the sodium content is pretty high. And then as I go over and I get to a higher price per serving, I notice that the sodium content gets lower. And just as a side note, these points down here I would consider outliers. We've talked about this vocabulary a little bit. These are just terms that are points that are outside of our regular, and maybe this one too we could kind of include in there. And so basically I'm not going to worry about these. I want to just look at the general pattern. So just looking at these points, I can tell that as the price increases, so as price increases, sodium decreases. And so they're going in opposite directions. So if you remember back to our positive correlation with the height and arm span, they both increased at the same time. As your height increases, so does your arm span increase. So since these are opposites, and what I can tell is that it's going down from left to right, if I'm just talking about the general pattern, it's decreasing, it's going down, then I know that this has to be a negative correlation. So what that means is that when I'm writing an equation for our line, we're going to draw a line in here in a minute, we're going to have a negative slope. So we're going to talk about 4 steps that you can take to figure out the equation for a line. So first thing we need to do is just draw that line. So here's our step 1. I've also identified 2 points right on here just so that it's important that you know some of the coordinates. But I didn't want to put the whole table for this example. So once again, we're kind of ignoring these outliers. And step 1 is to draw a line that crosses through at least 2 points and is close to many other points. So as I look at this data, I know that I want to draw a line that goes through 2 points and goes kind of through the middle or close to many other points. So I've identified this point on the left and this point on the right as being points that I think will, if I go through those 2, it'll make a line that kind of goes through the middle of my data. So got my line drawn in there, and now I'm ready for my next step. We're going to write an equation for that line to help us do an estimate. Once again, there are not all points are on the line. Some are above, some are below. That's okay. Our line is just a general pattern, which is what we want. So I just copied over here our scatter plot with our line drawn in there, and our step 2 is to use those 2 points that we went through to find the slope, or m. Remember, we use the letter m to stand for our slope. So here's our formula. We're going to take y2 minus y1 over x2 minus x1. So y2 minus y1, I'm going to take the y coordinates of the points. And I would just call this the second point. This one is the second point. This is the first point. So I'm going to take y2, 170, minus y1, 252. And I notice right away, 170 minus 252, that's going to give me that negative number that we talked about with the negative correlation. Now, x2 minus x1, I'm going to use the x coordinates, x2 minus x1. So I'm going to use 27 minus 7. This top 170 minus 252 will give me negative 82. over 27 minus 7 gives me 20. And then when I divide the top by the bottom, I get negative 4.1. So that is our m, that's our slope. And we got our negative numbers, so that's good. And remember, what a slope means is how much the sodium is changing according to price. So that means that for every cent that you add on, every 1 cent that you add on to the price is equivalent to taking out negative 4.1 milligrams of sodium. Okay? Step 3. Step 3, we want to find the y-intercept or the b. So when we write our equation, we're going to have to find the slope and the y-intercept. So what I notice is the line I drew at first doesn't really cross the y-axis, which is what I need it to do for the y-intercept. So I'm just going to take a straight line, and I'm just going to extend, so you might use a ruler for this when you're doing it, extend it across so that it crosses the y-axis. And since this process is kind of a general process, I'm really not too worried if this is not exactly accurate. So I just want to find an estimate of what that point might be. So if I continue the pattern of the y-axis, this is going up by 50s, and the last one they had was 250. So I'm going to know that this is 300. So I'm going to say that the y-intercept is 300. That's where it crosses. So the y-axis, or the y-intercept, b, equals 300. And now all we've got to do is go to our form in step 4, and we have to write our equation in the form. The form is y equals mx plus b, where we're going to replace m from step 2 and b from step 3 with numbers. So going back, I'm just going to write y equals, replace m with our slope, negative 4.1, put that in front of x, that means times x, and then add the y-intercept from step 3, which we decided was 300. And now we've got our equation for the line that we drew to represent the relationship between price per serving and sodium content.